All right, cool. So first things first, this data, I do not want you to copy down. I'm just showing you guys what I got from my data so you can compare and contrast it because part of what you're going to be marked on is your accuracy and your precision. So when I'm talking about your precision, I am talking about checking that your data points are within a range of 0.3. So what that means is that my largest value and my smallest value, when I subtract it, should be within 0.3. If they're not within 0.3, we need to start excluding data or doing some extra data collection, which is what you guys were doing what you guys were doing today, which wasn't really a surprise considering it was your first time doing a titration. So I'd expect your data not to be good. So if I looked at my data right now and I took this one as my highest, which is my 10.5, and I subtracted away my lowest number, which is 9.45, and then I did an enter button, it tells me that the range is 1.05. So that's way too big. It is not a range of 0.3, so I need to exclude my data. I need to decide, am I excluding the highest number or my lowest number in order to fix that range? When I'm looking at this real quick, it probably makes sense to eliminate my highest values because I can see that the other ones are all sitting around around 9, and this is 10.5. The other reason why I'm going to exclude this one is because I can see that this one here is my rough titration. This is the first one I did to get a rough ballpark of what I'm working with, and then after that I did things a lot more accurately. The way we've been describing in class is, are you making the burette pee or drip? So this gives me an idea of my rough ballpark, so that way I can basically set my burette to P until about 9, and then I let it drip. Does that make sense?
Yes.
So that gives me a rough ballpark. So if I exclude this data set, then my highest value is now 9.7, and my lowest value is 9.45. So if I do, I want to clear that, 9.7 minus 9.45, enter, my range is 0.25. So when I check the range of that, it's 0.25 milliliters. So I'm happy with that. I should go ahead and use those numbers. So double check your numbers. That's the first thing you want to do. Just as a reminder for the assessment criteria, let me show you where that is. So here, it comes up twice. It comes up in part B. So the data that I will give you, it's very likely I'm going to give you data that is not concordant to check that you know how to do that. Again, this is part C that we're working on right now. This is the data you are collecting. So you need to make sure that when you're collecting data, it's within 0.3. All right? Questions, concerns, comments? All right. So now that I know that information, I'm just going to average these three numbers. You're allowed to have 4 if the data is good. But if not, that's fine. Now, something to make sure when you're doing this is that you don't do something silly and add in this number that we said we're going to eliminate. I have seen that people do that, which is kind of crazy, that they clearly crossed it out, but then wrote it in their math. And I was like, why did you do that? All right. Other thing is you're dividing it by 3. When you're entering into your calculator, be very careful. You don't want to add all these numbers together and then hit divide by 3 because the only number you're going to divide by 3 is the last one. Let me show what I mean. So 9.55 plus 9.45 plus 9.1 divided by 3. If I did it like that and I push enter, my average is 22.23. Does that make sense for an average? Is that in the middle of the 3 values I had? No. So that's pretty obvious that you haven't done your math right. So 9.55 plus 9.45 plus 9.7. Hit the enter button or put things into brackets. Then divide by 3. Now I got 9.55. Did I do that right? Oh, I did something funny when I was adding it. Just check. All right, so I got my average to be 9.5666. Repeat. So I'm going to round that up because if I go 6, look over to the 6. 6 is bigger than 5, so it's going to be 9.57 milliliters. Now, something to keep in mind, this one does say 3 sig figs, including units. So those are things I'm looking for the merit. I always note it when I want it because that's when I need it for your assessment. Let me just find my green piece of, there we go. So 3 sig figs, and that's my units. Cool? Now, what does this mean for you guys? For you guys, this is the answer that I got. you have to be accurate to my answer. So that means you are allowed to be 0.4 below or 0.4 above. So the range that I'm looking for the accepted answers is I would be accepting anything from 9.17 to, I think it's 9.97. So this is the range that I'm going to accept. You need to be either above or below that number, okay? If you're not in that range, you're stuck at achieved. So let me just show you guys the marking schedule again. All right, here it is. Average titer is within 0.4 of the expected value, which is determined by the teacher's titration and expected calculation. All right, so hopefully you guys are there. If not, you are stuck at achieved because you've collected your data, but it's not good. Okay, I'm gonna come around and see your numbers. So I'm curious to see how you guys did. All right, are we good so far? All right, do you guys want to give the calculations a go, or do you want me just to do it? Just do it, okay. All right, so this is very similar to part B, it's just working in a different order. So if you guys remember when we did part B, we were doing this towards the end. Trying to find part B. Here we go.
Even if you use a 10.60, it's still above the range.
Just trying to find part B. Right, if you remember in part B, we started with the acid concentration. We used the mole equation and the concentration equation. And then we compared it against our titrate volumes to then figure out the concentration of sodium hydroxide. I am doing the exact same thing, except in a different order. I'm starting with the base, and I'm working towards the acid. Okay? Same calculations, different order. All right, so I have my volume here. They want you to use the average titrate that you calculated in question 7 and the unknown concentration of sodium hydroxide, which they've told me is 0.01 moles per liter, and calculate the amount of moles of the sodium hydroxide that I had in my flask when I did that titration. So concentration is equal to N divided by V. That's my equation, which I think I gave you guys somewhere else. I'll give it to you again. It's usually written on the pieces of paper. All right, I want to rearrange the equation for N. So in order for me to do that, I'm timesing each side by volume. The volume cancels out and I get N equals V times C. So if I know my do you want me to backtrack? I'm sorry, I gotta teach you some algebra.
So
The other option is we put in the numbers and you can rearrange it. Okay, I'm gonna show you both ways. So that way is me rearranging it with just the letters, because I personally like the letters. What I've done is I have the original equation as C equals N divided by V. I want to get N by itself, so in order to do that, I need to do the opposite of what's happening. So right now it's getting divided by V, so I need to multiply by V to get rid of the V. Since I did multiply on this side, I have to do on the other side as well. And that's how I got this new equation. The same one, just I move things around. If you do not like that, you are welcome to plug in the numbers, because some people like the numbers instead. So if I had C equals N divided by V, well, concentration is 0.1 moles per liter, equal to N, which is my unknown, divided by my V. My volume is from this question here. I just need to make sure I convert it. Why is there so much talking? If you understand it, that's great. But other people don't. Now, I have to be mindful that for my volume, it needs to be in liters instead of milliliters. So I need to divide it by 1,000. So 9.57 divided by 1,000 is 0.00, I believe. Oh, wow, we ran out of time. Great. So, I will finish recording the video. I'll put it online. Feel free to try doing the calculation because it's good practice. All right, I won't see you guys until the break. So, yeah, just on the sink. So have a good break. I will upload this video. Keep doing some practice with the calculations. All right, I'll finish up the video. Yes, because I was wrong. We do actually have no school on Thursday. What? I was wrong. All right.
Bye.
Bye. 1, 2, 3. Yeah, cool.
Bye-bye.
So if I want to, yeah.
You want to plan the face and our family, we think let's get up down.
No, if you're confident that you have it the right way around, you can put it back in the container.
Some of the lost baby.
Where's Spencer? Fine, go.
Thank you. Now, it's gonna rain, I'm not gonna be reading.
I don't know. I don't know what to do with it. There we go. All right. So I'm just going to multiply those two numbers to get the moles, and the liters cancel out. Bye. There we go. That's n equals 0.000957 moles. That's the number I'm getting. Pick one.
Too many zeros.
I know. I got it up on the board if you guys want to keep following along.
You see, which one? Well, yeah, I think you left your jacket. I think it's pick. Oh, it smells good.
Yeah, someone sprayed something else.
Should I do? Seems the same.
All right. The other thing to keep in mind is that's a 1-to-1 ratio, so you don't have to worry about timesing anything or dividing anything. Yeah? Hold on, let me just pause the recording. Yeah, look at that.
Oh, that's kind of like.
It's not calc, it's just algebra.
No, I know, but it's like similar to what.
Oh, so what you're doing in calc.
So,
Yeah, so we got a 1-to-1 ratio. I like how you came back here. Huh? For the candy. You just came back for candy even though you're at a music lesson. Okay. Make sure you spray and wipe down the tables.
Yeah.
I'm just trying to think what else we need to do. Okay, so we know that concentration, we know the volume. The volume of lactic acid we used from the pipette, which was 10 mils. So you have concentration equals N divided by V. Concentration equals 0.000957 moles divided by that, which is 0.01 liters. Cool. So the concentration of the lactic acid was 0.0957 moles per liter. And that's the answer.
Turn around.
There you go. You're now in the video now. All right, there's the answer. You're basically doing the same calculation, just working in reverse. Make sense? All right, and the other thing to keep in mind is that for the merit, I just need you to do the calculation either in the part B or part C, but for the excellence, I need you to get it right in both part B and C. Thanks.